हेलो एवरीवन, कैसे हैं आप सभी। आई होप सभी अच्छे होंगे। तो आज हम नया टॉपिक लेके आ रहे हैं जो आगे जो भी हम फिज़िक्स पढ़ेंगे उसमें सबसे ज़्यादा इम्पोर्टेंट रहेगा कुछ भी करने के लिए। तो आज का टॉपिक रहेगा हमारा वेक्टर। तो है इंट्रोडक्शन ऑफ वेक्टर। तो आज हम वेक्टर पढ़ेंगे। तो पहले जानते हैं वेक्टर होता क्या है। तो कोई भी फिज़िकल क्वांटिटीज़ कोई भी जिसमें हमारे पास उसका मैग्नीट्यूड हो, उसका डायरेक्शन हो, और तीसरा मेन पॉइंट है कि जो वेक्टर का जो लॉ होते हैं वेक्टर अलजेब्रा के उसको फॉलो करता हो। तो है ओबे लॉज ऑफ वेक्टर अलजेब्रा। ठीक है, तो ये हमारी 3 कंडीशन है। कोई भी फिज़िकल क्वांटिटी अगर वेक्टर कहलाएगी तो तीनों कंडीशंस को सेटिस्फाई करना चाहिए, तभी वो वेक्टर कहलाएगी, वरना नहीं कहलाएगी। अब हम एग्जांपल लेते हैं कि क्या कौन कौन से वेक्टर्स होते हैं। जैसे मान लीजिए हमारा डिस्प्लेसमेंट है, वेलोसिटी हो गया, एक्सेलरेशन हो गया, फिर मान लीजिए फोर्स हो गया, मोमेंटम हो गया, और जैसे हमारा टॉर्क हो गया, एंगुलर मोमेंटम हो गया। तो यही एक्सेट्रा कर देते हैं, और काफ़ी सारी होती हैं। तो इन सब में आप देखेंगे तो क्या चीज़ कॉमन है कि डिस्प्लेसमेंट में भी अगर मैग्नीट्यूड होता है तो यहाँ पे डायरेक्शन भी मेंशन होता है। जैसे अगर हमारा एक डिस्टेंस होता है तो डिस्टेंस में हमें सिर्फ मैग्नीट्यूड होता है कि भाई कोई इंसान गया 5 किलोमीटर गया कि 10 किलोमीटर गया, बट इसमें ये नहीं बताया जाता है कि किस डायरेक्शन में गया, कि नॉर्थ में गया, साउथ में गया, ईस्ट में गया। बट वहीं अगर डिस्प्लेसमेंट आ गया तो डिस्प्लेसमेंट का मतलब है मैग्नीट्यूड तो बताएगा ही बताएगा कि भाई कोई पर्सन कितना गया, 5 किलोमीटर चला या 12 किलोमीटर चला। इसके साथ साथ ये बताएगा कि मान लीजिए 5 किलोमीटर किस डायरेक्शन में गया, तो ईस्ट डायरेक्शन में गया। 12 किलोमीटर किस में गया, नॉर्थ ईस्ट में गया। तो नॉर्थ ईस्ट में गया तो डिस्टेंस मतलब मैग्नीट्यूड के साथ साथ डायरेक्शन भी बताया। तो ये हो जाएगा हमारा वेक्टर क्वांटिटी। और अगर देखेंगे, अगर इसको आगे सॉल्व करेंगे कि भाई वो वेक्टर अलजेब्रा के लॉज को फॉलो करता है तो वो भी इसमें ऐड हो जाएगा। तो ये फॉलो कर रहा होगा, तो ये हमारा वेक्टर क्वांटिटी हो गई। अब ये क्यों मैं बोल रहा हूँ कि वेक्टर लॉ फॉलो करना चाहिए, तो ये इसलिए है कि कुछ क्वांटिटी होती हैं कि मान लो से कुछ क्वांटिटी हैं कि मैग्नीट्यूड भी है उनके पास एंड डायरेक्शन भी है। ये दोनों कंडीशन सेटिस्फाई कर रही हैं, बट जो वेक्टर अलजेब्रा के लॉ हैं इनको सेटिस्फाई नहीं कर रही। तो अगर ये इसको सेटिस्फाई नहीं करेगी तो मतलब है कि ये वेक्टर नहीं है। वेक्टर होने के लिए ये तीनों कंडीशन नेसेसरी हैं कि तीनों सेटिस्फाई करें। इसका एग्जांपल देखें तो जैसे करंट है हमारा, करंट के पास मैग्नीट्यूड भी है भाई कि भाई इतना एम्पियर, मान लीजिए 5 एम्पियर का करंट आया या 10 एम्पियर का आया, तो ये तो मैग्नीट्यूड भी हो गया। डायरेक्शन भी है हमारे पास कि डायरेक्शन किस में गया, कि साउथ में गया, कि ईस्ट में गया, कि वेस्ट में गया। तो जब आपको सर्किट डायग्राम जैसे बनाएंगे ये हो गया, मान लो ये इस डायरेक्शन में जा रहा था, यहाँ पे ये नॉर्थ में गया। मान लीजिए ये नॉर्थ है हमारा, ये साउथ है, ये ईस्ट और ये वेस्ट, तो ये नॉर्थ में गया, फिर यहाँ पे ये ईस्ट में जा रहा है, फिर इधर साउथ में इस डायरेक्शन में वेस्ट में जा रहा है। तो हमारे पास और कितना करंट जा रहा है, मान लीजिए 10 एम्पियर है, तो 10 एम्पियर करंट फ्लो कर रहा है, किस डायरेक्शन में कर रहा है वो भी पता है। बट जो हमारा ये करंट है, ये वेक्टर अलजेब्रा के लॉ फॉलो नहीं करता, वेक्टर अलजेब्रा लॉज ये फॉलो नहीं करता है। तो इसलिए ये जो करंट होगा हमारा, करंट इज़ नॉट अ वेक्टर, करंट जो है वो वेक्टर नहीं कहलाएगा हमारा, क्योंकि वेक्टर कहलाने के लिए तीन मेन इंपॉर्टेंट चीज़ें हैं, तीनों सेटिस्फाई होना चाहिए। तो मैग्नीट्यूड भी होना चाहिए, डायरेक्शन भी होना चाहिए, फिर जो वेक्टर अलजेब्रा के लॉज हैं उनको भी फॉलो करना चाहिए। ठीक है, तो ये तो हो गया कि कौन सा क्वांटिटी वेक्टर कहला सकता है, तो ये हो गया हमारा। अब आते हैं हम नेक्स्ट टॉपिक पे कि किस टाइप के वेक्टर्स होते हैं एक्चुअल में। तो आते हैं कि टाइप्स ऑफ वेक्टर। तो टाइप्स ऑफ वेक्टर, तो जिससे अब ये तो हमें पता चल गया कि भाई मैग्नीट्यूड होगा, डायरेक्शन होगा, तो किसी भी क्वांटिटी में मैग्नीट्यूड और डायरेक्शन आ जाएंगे। अब लॉज क्या होते हैं वो आगे बताऊंगा, पहले हम लोग ये देख लेते हैं कि किस टाइप के वेक्टर होते हैं, फिर देखेंगे कि कौन कौन से जो लॉज होते हैं एक्चुअल में, जो मैं बोल रहा हूँ कि लॉ फॉलो होने चाहिए तभी वेक्टर कहलाएगा, तो वो पढ़ेंगे। पहले आएगा टाइप्स ऑफ वेक्टर, किन कौन कौन से टाइप होते हैं। तो पहला जो है हमारा वो है इक्वल वेक्टर्स। इक्वल वेक्टर्स जो होते हैं, मान लीजिए हमारे पास दो वेक्टर हैं, टू वेक्टर्स ए वेक्टर एंड बी वेक्टर। Then if we have two vectors a vector and a b vector, then they are said to be equal vector when they have same magnitude, same magnitude and also same direction, same direction. We can say if they have they need to have same magnitude as well as same direction. Even like if a vector going in each direction and let's say b vector moving in a west direction, then we can say, like, if we represent the a vector as a positive, then b vector will be negative because the directions are opposite. So the value of the vector will be the magnitude will be the same, but the sign or the direction will be the opposite, so they are not called as a equal vector. So for equal vector we have the vectors have to satisfy the both condition, like they need to have same magnitude as well as same direction. Like if a vector is in each direction, b needs to be in a east direction, if a is in a north direction, then b needs to be also in a north direction. This is the first type of a vector, equal vectors. Now come to the second type of a vector. It is parallel vector. Parallel vectors. So the parallel vectors are the vectors which have same direction, but there's no need for the same magnitude. So we can say, let's say this is a vector having sorry, it's going in an east direction, okay, and it has a magnitude of 5. Like any we can consider 5 meter or anything, that depends on the quantity we take, but let's say the magnitude is 5 and it is going in a each direction. Then there's a vector b vector which is also moving in a each direction, but the magnitude is 8, like anything 8 or 9 or 15, any magnitude, but the direction is same. Then then the vectors are said to be parallel vectors. Like parallel vectors are, like, sorry, if the two vectors are known as parallel vector when both of them have same direction. We need to remember this. The two vectors are said to be parallel only and only when they have same direction. There is no need for the same magnitude. Magnitude can be any value like 5, 10, 15, anything, but they need to be in a same direction. Then only the both vectors are called parallel vectors. Similarly, if we take anti-parallel anti-parallel vectors, then you can say the two vectors are anti-parallel vectors when both of them are in opposite direction. Like in parallel vector, the two vectors need to be in the same direction, but in anti-parallel vectors, like the name suggests, anti-parallel, this means the direction of the both vector should be opposite to each other. This angle between those two we can say the angle between those two vectors should be 180 degree. Like let's say this is a vector and its direction is in east direction, anything, and the b vector, its direction is in west direction. If this is west and this is east, the magnitude, like similar to the parallel vector, it does the magnitude doesn't affect any of these. We only need to consider the direction of vectors. If they have the same direction, like in a parallel vector we need the both vector have the same direction, but in anti-parallel, like name suggests, anti and parallel, so they need to be in opposite direction. If one going in east, the other should be in west direction. And considering this, the angle between the both vectors should be 180 degree. uh, Angle between both vectors should be 180 degree. So this is the anti-parallel vectors, which the magnitude doesn't depend, and the only thing you need to consider is that both the vectors have an opposite direction, or we can say that the angle between them is should be 180 degree. So the next type of vectors are collinear vector. The collinear vectors are the vectors that lie on the same line or parallel to the same line. Let's say this is the line A vector. This is a vector A vector and it's in direction east. And let's say a B vector in the same line, like the so let's consider this line, and b vector is in the same line, but the magnitude doesn't matter here also. So it, let's say a vector have magnitude of 5 and b have magnitude of 4, but it's in the same direction. Yeah. Sorry, same line. It needs to be in same line or parallel to the same line, the given line. So b vector is also in a east and on the same line, or let's say c vector which parallel but going in the same direction. Let's say the magnitude of c vector will be 3. Then we can say the vectors are collinear. Let's define it. The vectors are said to be collinear if it is in same line if it lie in same line or parallel to same line, regardless it of its magnitude or direction. Okay, uh, I got mistake at one step. So the collinear vectors are the vectors which lie on the same line or parallel to the same line. So let's say is lying in the same line and C is parallel to the A vector, but the direction doesn't matter. So even if it's not going in a east direction, it's going in a west direction, like, or east direction, doesn't matter. The thing only matters is that the both vectors are going in a same line or the both are parallel to each other, then it is said to be a collinear vector. Then coming to the next type of vector, it is zero vector. Zero vector. So zero vectors are the vectors which have a zero magnitude and can be any direction. So direction doesn't matter if you don't have a magnitude. Like if I put a point like this is the point. How can I define that it's in a north direction or south direction or any, like, north south any direction? So there's no there's no not point of there's no point of direction. So we can say a zero vector, a vector which have zero magnitude regardless its direction. So, like, it is if a vector have zero magnitude, then it is known as a zero vector. Like, for an example, a point is said to be a zero vector because it doesn't have any magnitude. So if you can't define even a direction for it, like it's going in a south or north, so it's called a zero vector. Coming to the next vector type of vector, it is unit vector. Unit vector. So the vector which when divided by the magnitude of a vector, then the value which comes out is a unit vector. Let's say a vector divided by its magnitude is a unit vector. So let's say there is a vector A. This is a vector A, and its magnitude, let's say magnitude is A. So the unit vector is represented by a cap, like like this cap on top of the alphabet. So, or vector. So a cap is equals to a vector. For vector to represent like vector, we put arrow sign above alphabet. So if it is normal alphabet, like say let's say A, then it is showing the magnitude of that vector. But if we put A and then arrow, then it is representing a vector. And when A comes with a cap on top of it, then we say it's this unit vector. So unit vector A cap is equals to a vector A, and when divided by magnitude, so magnitude is A and divided by A. So unit vector, the vector and divided by its magnitude, the value comes out is said to be a unit vector. And the important thing about unit vector is that unit vector only defines the direction of a vector. It defines the direction of vector. So we can say from that, here we can say from here that, let's say a vector is equals to a multiplied by a cap. So when a magnitude is multiplied by a direction, then it's give a vector, proper vector. So magnitude multiplied by direction is given gives the proper vector. So this is a unit vector first. Let's come to the next type of vector, which is orthogonal unit vectors. Number 7, orthogonal unit vectors. So orthogonal unit vectors, like from the first word orthogonal, we understand. Let's understand what is orthogonal. So orthogonal are the vectors which are perpendicular to each other. So the vectors which comes under this are perpendicular to each other. Let's say these are the three vectors, like in the direction of x is in the Cartesian plane. So let's say x-axis, y-axis, and z-axis. So the unit vector, we learned that unit vector only tells about the direction. So here orthogonal unit vector means the unit vectors which are perpendicular to each other and gives the direction. So let's say in the direction of x-axis there is I cap, because for unit vector we put cap on top of an alphabet. So I cap, and in direction of y axis it's j cap, and in direction of z axis k cap. So we have three orthogonal unit vectors for 3D Cartesian plane. For 3D Cartesian plane, we have three unit vectors which are perpendicular to each other, just like the axes of Cartesian plane, Cartesian space. So it's these are I cap, j cap, and k cap, where I cap is along the x-axis and j cap is along the y-axis and k cap is along the z-axis. And from considering the axis, we say, let's say here x-axis, in along x-axis there is x vector, and when divided by magnitude of x, it gives the unit vector along the x-axis. So unit vector along the x-axis, we represent it by I cap. So I cap is equals to x vector upon x. Similarly, the j cap will be a vector along y-axis, the y vector, and the magnitude y. And similarly, k cap will be z vector upon z magnitude. From here we can say that the x vector is equals to x I cap, and the y vector is equals to y j cap, and z vector is equals to z k cap. So these are the orthogonal unit vectors. Orthogonal means perpendicular, perpendicular to each other. The vectors should be perpendicular to each other, and these are along the three axes: x-axis, y-axis, and z-axis. So these are the three orthogonal unit vectors, which is represented by represented by I cap, j cap, and k cap. The next type of vector are polar vectors. Polar vectors. So the polar vectors are the vectors which like changes its direction with the when coordinate axes are reversed. Like let's say this is a radius vector r. Let's say this r vector, and that's in the direction of y-axis, and this is our Cartesian space x y z, like space. And if we reverse the Cartesian space, like let's say in this direction there will be x-axis, and in this direction there will be y-axis, and in this direction there will be z-axis. So, and the direction of our r vector is here. So axis y-axis is in now y-axis is in west direction, while the our vector is in east direction. So you can say the polar vectors are the vectors which reverse its direction. Polar vectors are vectors which um, reverses its direction when coordinate plane reverses flipped, like plane reverse or flipped. So if I've given you the example, let's say this is the plane p, and the coordinate plane p, and when it reverses it or flipped, the direction of r vector is now reversed, because the y axis is in a west direction. So let's say the direction of y axis is positive. If we assume the direction of y-axis is positive, then after flipping the coordinate plane, the r vector is going in the opposite of y-axis. So the r vector and direction. So the direction of r vector is negative. So this is a polar vector. The polar vectors are which changes its or reverses direction when the coordinate plane reverse or flip. Now coming to the next vector, that is axial vector. So it's number 9, axial vectors. The axial vectors are vectors which comes under effect on rotational motion, like in angular momentum. Like example, these are the examples: angular momentum, or these kind of there then axial vectors come into effect. These are solved by the right hand rule. It's like let's say this is a vector, and it is rotating in anti-clockwise. So angular, like examples are angular momentum or angular velocity or torque. So in axial vector, let's say the vector is it is solved by the right hand screw rule, where you can the direction in which you fold your fingers, like if you fold your fingers in anti-clockwise manner, then the direction is given by your thumb direction. So let's say you're folding your fingers in anti-clockwise, so the direction is in the north direction. So that's a axial vector. This is our axial vector. So the axial vectors, we can say axial vectors are always in direction of axis of rotation. Let's say any matter or particle is rotating anti-clockwise. So by using our right hand screw rule, let's say our finger are fold in anti-clockwise matter, and the thumb shows the direction. So the x or axis of rotation. So axis of rotation of this particle is this, and similar, and the axial vector is also in the direction of your thumb. So the axial vectors are always in the direction of axis of rotation. So we can say where's the direction of axis of rotation is the direction of axial vector. Like this is let's say now we are folding our fingers in clockwise matter. So now the axis of rotation will be in the direction of our thumb. The axis of rotation will be downward, let's say south. And similarly, the if we see the thumb is in the downward direction. So the thumb direction shows us axial vector. So the axis of rotation and the axial vector are in always in the same direction. So for definition, we can like if we conclude the axial vector, we can say these vectors represent rotational effects and are always along the axis of rotation. So these vectors represent the rotational effect of it represent rotational effect and always in the direction of axis of rotation. And we saw examples like angular momentum or angular velocity or torque. These are the example of axial vector. Now coming to the next type of vector are coplanar vectors. Coplanar vectors. So the coplanar vectors are, say, we can say that if we take a number of vectors like 2, 3, or 4, so any number of vectors, if they lie on a same plane, like let's say this is our plane, xy plane, like xy plane. This is our xy plane, let's say, and the number of vectors like this is a vector, this is b vector, this is c vector. So in a coplanar vectors, all vectors lies on same plane, like this is our xy plane, and a vector, this b vector, this c vector, or all lying in a same plane. So we can say that a vector, b vector, and c vector are coplanar vectors. So it doesn't matter what their direction is, what their magnitude is. If they are in a common plane, like same plane, then the vectors are said to be a coplanar vectors. It doesn't matter they have if they have different magnitude or different direction. One is going in a east or one is going in a south. It doesn't matter. The only thing matters here is only thing important here is a same plane. The plane needs to be same. Like here I have took example of xy plane. It can be any plane, xy plane, yz plane, or xz plane. Any plane. The it all matters that all the vectors lies on a same plane. So the vectors, if all vectors are lying in a same plane, then they are said to be a coplanar vectors. So uh, that's all. We have learned 10 types of the vectors. I can Let's revise it. The first type of vectors are equal vectors. In equal vectors, there are two or three or more vectors, but the condition is they needs to have a same magnitude and same direction. They needs to be have same magnitude. Like if this is 5 magnitude, then both the vectors have magnitude of 5, and they have both have same needs to have a same direction. And then other is our parallel vector. The parallel vectors are the vectors which are going in a same direction. Like if one is going in the east, the other should also go in the east direction, or we can say same. It need to be in a same direction. But the magnitude doesn't matter. Magnitude can be anything, but any value. But they need to have a same direction. Then we come to the anti-parallel vectors. Anti-parallel vectors are the vectors which are in a opposite direction. Here also the magnitude doesn't matter. The only thing matters they need to be in opposite direction, or we can say the angle between those vectors should be 180 degree. And then comes to the collinear vectors. The collinear vectors are the vectors which lie on a same line or the parallel to each other. They needs to be in the same line or parallel to the like to the same line. So let's say b here is a b vector and the a vector. These both are in a same line. So we can say the a vector and the b vector are the collinear vector. Here the direction and magnitude doesn't matter. The only thing matter they need to be in same line or parallel. Then fifth is zero vectors. Zero vectors are the vectors which have zero magnitude. So it doesn't matter what is their arbitrary direction, because I am saying arbitrary, or we can say imaginary direction, because if the vector has a zero magnitude, you can't define its direction, in which direction it is going. So you can say we are taking the imaginary or arbitrary direction. You can say if a vector has a zero magnitude, it is a zero vector. Then comes next unit vector. Unit vector is the vector when divided to its magnitude, and the value we get is the unit vector, and the unit vector defines the direction of a vector. Then orthogonal unit vectors, then like we say unit vector defines the direction. So orthogonal unit vectors are the perpendicular axes. So it defines the direction of perpendicular axis of our Cartesian space, or we can say coordinate plane. So xyz axes and the direction are represented by I cap, j cap, and k cap respectively. And comes to the polar vectors. The polar vectors are the vectors which reverses direction when the coordinate plane flipped or reversed. So let's say here is our coordinate plane x y z, having axis x y z, and this r vector parallel to the y axis. So if we flip the coordinate plane, then the direction of r vector will be minus, since we are taking the direction of y-axis as a positive, so the direction of our vector will become negative. Then axial vector, these are the vectors which defines the rotational effect of that quantity, and they are always along the axis of rotation. And how do we find to find the axial vector or axis of rotation? We use the right hand screw rule. So the rotation of a vector is in the direction of our folding fingers, and the thumb represent the axial vector or the axis of rotation. Then the last vector is the coplanar vector. These are the vector which lie on the same plane. Doesn't matter what their direction or what their uh, magnitude is. They need to be lie in a same plane. So these are the coplanar vectors. So these are the all types of vector. We are finishing it here now. In the next lecture, we will study about the laws of vector algebra, which in the starting I told uh, about them, that these are the that these this is the necessary condition. Like we get if we get magnitude and direction, we also need to verify that if the physical quantity is obeying the laws of vector algebra. So what are these laws of vector algebra? We so we're gonna study about them in the next lecture. Till then, goodbye and thank you. Actually, I'm trying to improve my English, so I decided to start teaching in English. In that way, my English, like spoken English, also improves. Like you've seen how like I'm fumbling a little bit, but I think with time I will improve myself. So, and you also keep studying and improve your physics and whatever. If you have any other doubt, you can also comment below. I will definitely help you out and help you grow better. Till then, thank you and goodbye. Take care.